All right, so basically L'Hopital's gives us the ability to evaluate limits that previously would have been very difficult for us to evaluate. And we looked in the previous video about the situations where the 0 over 0 case. L'Hopital's also applies to another indeterminate case that we will just refer to as infinity over infinity. Okay. All right, so let's look at an example. So the limit as x goes to infinity of 3x plus 5 over 2x plus 1. All right, so that is an infinity over infinity. Notice if you plug in infinity into the numerator, then the top goes to infinity and the bottom goes to infinity. All right. Now I will say this: if this is also, this could be, one could be infinity, the other could be a negative infinity. Uh, they could be opposite signs, but they both apply. L'Hopital's applies to that as well. But L'Hopital's just says, look, if you end up with infinity over infinity, then you can apply L'Hopital's rule just in the same way that we did before. We don't have to do anything different. Take the derivative of the top over the derivative of the bottom, and now find the limit. And of course, as x goes to infinity, 3 halves just stays 3 halves, right? So it's very, very useful. All right, let's look at another one. The limit as x goes to 0 from the positive side, from the right side, of ln of x over the cotangent of x. Okay, so we got to remember how these things work. Uh, Natural log, as x goes to 0, natural log is going to negative infinity, right? As x goes to 0 from the positive side, natural log goes to negative infinity. And cotangent, because we've got an asymptote at 0 in the cotangent graph, you can graph cotangent to see that, but it goes to infinity, right? So again, we can apply L'Hopital's rule, which just says, well, since we've got that indeterminate case, just take the derivative. Natural log of, or the derivative of natural log of x is 1 over x. The derivative of cotangent, and now the derivative of cotangent is negative cosecant squared of x. All right. And so this all becomes a limit as x goes to 0 of 1 over, or negative 1 over x cosecant squared of x. All right, so that's what that becomes. All right, so now, so if we look at this, we see that x is going to 0. As x goes to 0, of course, this x is going to 0, and this cosecant squared is going to infinity. So we don't really know what that is. 0 times infinity, or something really small times something really, really big. So we're still unable to evaluate the limit. So let's do one other thing here. We realize that cosecant squared is just 1 over sine squared. So let's move the sine squared up top, right? And so we're left with x. Now look, if we try to evaluate the limit, it's a 0 over 0 again. So let's apply L'Hopital's one more time. So we got negative. Derivative of sine squared is 2 sine of x cosine of x. Derivative of x is 1. And so now, if I plug in 0, I get 2 sine of 0. Sine of 0 is 0. Cosine of 0 is 1. So that becomes 0 on top and 1 on the bottom. And of course, 0 over 1 is just 0. And so there's our limit. All right, so we get a chance to evaluate. So again, it's important to remember this limit that we wanted to find at the beginning, bam, equals this. So even though we've gone through several iterations of problems here, then we or different looking limits, the limit is equal, and that's what L'Hopital's says. Now, it's important to remember L'Hopital's just can't, we just can't use it whenever we want. So for instance, if I have this right here, the limit as x goes to 1 of x squared plus 5 over 3x plus 4. And I can just plug the 1 in, right? So the 1 in gives me a 6 over 7. So the limit would be 6/7. If I mistakenly tried to apply L'Hopital's, I would take the derivative, 2x over 3, and now evaluate the limit. Oh, it's 2/3. You see that that does not work. Okay, L'Hopital's will only apply if the original limit you're dealing with is an indeterminate form. And so far we've talked about 0 over 0, or plus or minus infinity over plus or minus infinity. Those are our most common cases that L'Hopital's applies. Don't try to apply them any other places. Just apply them to those right there.